I'm going to put in sine of 90 minus, now you can of course do the same thing we did before, and instead of 90, you can choose a variable value, you can slide it around and you can see its effect. I will do that in a second, but before I do that, let's just put it in. So there's 90 minus x. Okay. So from the graph, rather mysteriously, I should say 90 degrees minus x, I'm getting the same graph I got for part A. Aren't I? It's cos x, right? It's cos x. Okay, now, why is this the case? Why is this the case? Because you have to understand what's going on. I'm going to give you two explanations. One is a simple one, which is actually a rehearsal of a previous explanation I gave you, which is fine. I hope it will convince you. But it's not enough, which is why I'm going to go into the second explanation. The second explanation, I'll warn you right now, it's harder, but it will yield you more insights if you take the time and effort to understand it. Okay, ready? Explanation number one. Simple. Here we go. Right angle triangles. That's where trig begins, right? So if I pop x over here, okay, and let's label our sides, shall we? It's right angled, so I'll make it A, B, and C, just like Pythagoras, okay? On this diagram, because it's right angled, this angle up here is 90 degrees minus x. Content with that? Okay, so here, sine of this angle, which is sine of 90 minus x, is opposite on hypotenuse. B on C. And in exactly the same way, cos of x, which is a different angle, is adjacent on hypotenuse. So it's also equal to B on C. Okay, so there's my argument. These two are equal, and this is why. But I wonder if you can see why this is not enough of an argument to take forward. Do you remember why we introduced the unit circle? Think back a few lessons. Why did we do that? What's the point?
To explain the ratios.
Okay, so we had quadrants, we had negative angles, we had angles that are bigger that can fit in a triangle, right? This argument here is only justified for acute values of x, right? As it happens, it looks like it's true for all of them. Like look, it's cosine all the way. It's not like it's cosine sometimes, and then it changes rules. So we need a better, more sophisticated way to demonstrate this. Okay, so here's the way I'm going to do it. Let's start with this, sine of 90 minus x. Okay, so what I'm going to do is I'm going to try and bring together some of the knowledge we already have and apply that to this, okay? 90 minus x. This is a bit funny. If I wrote this in the correct order, it would look like this, okay? Now you're like, well, what's the difference? The difference is it makes it clear what's happening to the x and which direction the shift is going in, okay? So think about this. If I graph this, and now I'm going to go into my slide, and you might like to follow me, okay? I'm going to graph this as minus x plus a. Okay, now if you go back, right, what just happened there? Like there's sine of minus x. I haven't added the shift in yet. What is this thing? Now you have to be careful, because this thing is symmetrical. A couple of different things look like they're happening, but really only one thing is happening. Sine of minus x, that minus there, minus signs, what they mean is opposite direction, plus and minus, okay? When you apply it to an x, that means flip horizontally. If you were to apply it to a y, it would mean flip vertically, okay? But the thing is, because this function has symmetry, because it's an what kind of function? What kind of symmetry does it have? It's an odd function. Because it's an odd function, that's what my next guess is going to be. If I flip horizontally, which is what I've done, right? It's going to look exactly the same as to if I flipped it vertically. Okay, can you see that? The blue graph is the red graph upside down, and I can take advantage of that. I know that this is equal to minus sine x. Do you remember when we were talking about odd and even functions? And we said this? Sine of minus x equals minus sine of x. That's what defines an odd function. Okay, all right. I'm going to come back to doing this shift in here. So I got my minus there, and I'm going to add a. Okay, so let's add a slider in there. And let's make these values a little more helpful. 0 to 360, steps of 15. Okay. So what do you expect to happen? This is the blue graph, right? This is the blue graph, and it's a plus. It's a plus. So which way is it going to go?
Left.
Hold on a second.
Wait, it's because it's negative.
What's happening? What's happening? You have to think about this very carefully. Let me do it again, just so you can convince yourself of what's actually happening. When I move it this way, what's going on? It's going to the right. Let's just hit adding. It's going to the right, but we just labored the point before that if I give you this, I don't know if this is on the video, right? If I give you this should go to the left. Shouldn't it?
Wait, is it because it's going the anti-clockwise direction on the circle?
No, it's because if you took the minus.
So what's really going on? This is very, very sneaky. Okay, you want me to show you? I'll show you what's going on. See this, right? I'll just let that keep doing its thing. Okay. This is a bit sneaky. What it really is this.
Yeah, there we go.
Now you're like, what just happened? What just happened? I'll show you what happened. This minus sign, right? It's taking everything in here and it's flipping it round. Flipping it around, okay? Then this moves you in what direction?
One direction. Yay.
I'll tell you a funny joke about that at the end. Remind me, okay?
To the right.
This is going to the right. It's going to the right, okay? It's supposed to go to the right. X minus something is a rightward shift. It's a positive shift, okay? So this minus sign out the front is flipping the whole thing, and then this minus 90 is moving me to the right. Okay. So now let me just lock it in it. Let me pause it and bring it back to 90. There it is. Okay. So it was flipped and then it moved. It's flipped and then it moved. Okay. However, because that means it was moving the opposite direction, right? That's just like the first graph we were doing, which ended at cos, right? So that's why, well, no surprise that these two graphs, A and B, are going to give you exactly the same graph. Okay. So, does that kind of make a little bit of sense? Play with it a little more, explore it. I could make you, like, I just drew these out, and that's how I got the understanding. But it's so much better when you can actually move back and see what's going on. All right, let's have a look at part C. We can do this a bit quicker now that we've done some of the harder ones, okay? Let's do this. So we'll do this really quickly. I'm going to make my original graph cos.
Wait, so
There's cos.
wait, why does it?
And then I'm going to put on
I
there.
don't get why. So we don't get the proof.
Which part?
Like, I get that, and then I'm just like, what happened? Yeah.
Okay, so what it did was the minus sign flips things around horizontally. Okay, flips things around horizontally.
Okay.
But this minus 90 moves things to the right.
But why does it flip it horizontally? Why doesn't it flip it like that?
Because the minus is applied to x values, not to
Wait.
y values.
What?
Whoa.
Oh, that's confusing.
So let me show you this way. Okay, let's let me think of an example. We'll go with cos. Okay, we'll go with cos. Okay, if I said to you cos of x, you know what that looks like. Is that okay? In fact, there you go. There you go. Now, if I compare that to cos of minus x, pause. What's it going to do? How would you verbalize it? Answer, there's a flip happening, and it's happening to the horizontal direction, right? And so sure enough, you ought to expect, because cos is an even function, there he is, and they're on top of each other, because these two graphs are the same, right? Okay, now, that was in one direction, okay? Here, let's go in the other direction. Now, we usually say y is the subject. That's the normal way we write equations. Y equals this, y equals that. So if I gave you this, you wouldn't bat an eyelid, right? Except this kind of clouds what's going on. This minus isn't really over here. A more helpful place to put it is over here. Because this clarifies what's being flipped. Tell me what's being flipped.
Oh,
It's going vertically, right? Which is why, sure enough, when you graph, right, minus y equals cos of x. Right? There's minus cos. Right? It's the red graph flipped vertically upside down. Okay? So what you put the minus sign on affects what you're flipping. And here, the minus signs are all on the x's. They don't even touch the y's. They're not even close. Okay? So that's what's happening in here. And then x minus 90 shifts it to the right. That's what we saw when we mucked around with it. Okay, and in fact, if I change this to 100 or 120, it's going to go further and further to the right.
So the sine graph gets flipped and then moves to the right.
It doesn't get flipped, it gets flipped.
Okay.
Okay? Just watch out for this, okay?